Lesson 6.3 is titled Logarithms. In this lesson, we will write logarithmic expressions, simplify, evaluate logarithms, and we'll actually solve logarithmic equations. To get into why the word logarithm was necessary, let's look at example 1 first. It says solve the equations 2x equals 10 and 2 to the x equals 10. If we have 2 times x equals 10 in that first equation, and we want to get x by itself, we would just divide by 2. And we'd simply get x is equal to 5. Easy enough. We run into trouble, however, when x is an exponent and not just in a product. 2 to the x power equals 10. If we use our power chart, 2 and 10 aren't a match on there. We would need to figure out a way to guess and check on our calculator to figure out this answer. What we're doing is actually finding inverses. The inverse of multiplication is division, and that opposite operation allowed us to solve for x in that first equation. But what's the inverse for this exponential? How could we use that information to get x by itself? This is where the term logarithm comes in. The definition for logarithm is the inverse of an exponent. For example, if we say something to the effect of let y equal b to the x power, then the inverse is, or we'll say the inverse would be, and what we actually do is we take the 3 letters in front of logarithm as a prefix. We call it log. The inverse would be y equals log base b of x. Notice that b is smaller. It's like a subset number or variable. So it's like a lowercase kind of in that situation. Some other things to note: b has to be greater than 0. It can't equal 1. And x also has to be greater than 0 in order for this to work. Now, a logarithmic function, and I'll just put this actually over here right next to it, is the inverse of an exponential function. That'll be good to know. The definition of a logarithmic function is the inverse of an exponential function. Here's how we do this. To convert from one form or the other, or to the other, we're going to loop the forms. This is what I mean. In example 2a, it says, what is the logarithmic form of 3 to the 4th equals 81? Well, 3 to the 4th equals 81 is exponential. To loop it for logarithmic, what we're going to do is just write out the word log. Actually, I meant to write, oh, never mind. All right, here we go. We're going to write the word log, and then the base 3 is going to be the subbase 3 here. Let's make sure we can read that. So the base for the exponential is the base for the logarithm. And then here's what I mean by looping it, where the 4 isn't going to be next. We're going to loop it to the other side and actually take log base 3 of 81. And we equal it, we're going to loop it back, and that's where the exponent goes. Log base 3 of 81 equals 4 is the inverse of 3 to the 4th equals 81. All we're doing is just changing the form from one to the other. Let's try it the other way. What is the exponential form of log base 10 of 1,000 equals 3? If we have an log prefix in our work, we know that's a logarithmic equation. There aren't any exponents here anyway. To loop it, we now start with our base. Our base is 10. For our exponential statement, it's going to be 10. And then we do that arrow looping. We're going to raise 10 to an exponent of 3, and it's going to equal 1,000. And again, all you're doing is changing forms. We're not solving anything in this step. We're just going from one form to the other, either exponential or logarithmic. When asked to evaluate a logarithmic expression, what you simply want to do is When asked to evaluate a logarithmic expression, what you want to do is create an equation and loop it, just like we did up above. You'll then want to use your power chart, if you have one, or a calculator to solve. And here's what I mean. Did I spell that right? There we go. Calculator. Okay, let's try a couple. It says, what is the value of each logarithmic expression? In that first one, log base 5 of 125. To create an equation, we just want to set this equal to something. Let's set it equal to x. Since it's a logarithmic equation, we're going to convert it to loop it, converting it back to exponential. The base for the logarithm is 5. That's going to be the base for my exponential. I'm going to raise it to the x power. So this is where we might have to guess and check. But I'll set it equal to 125. 5 to what power equals 125? You could guess and check on your calculator if you didn't remember this answer, or if you have a power chart lurking somewhere in your folder, this would be a really quick answer. Either way, you should get x equals 3. 5 to the third power equals 125. Let's try another one. Log of 1/4, let me say it one more time. Log base 1/4 of 16. You think I hadn't done this for a while. And we want to evaluate this expression. Again, let's set it equal to a variable. We'll set it equal to x. This one might be a little trickier. Let's see what we can do. Now our base is a fraction. It's 1/4. I'm going to put that in parentheses. Is equal to 16. Now let's see if we can figure out how to make this work. If you remember, 1/4 as a fraction would be 4 to the negative 1 power if we put the 4 back up on top. That's an x right there. So then that would be 4 to the negative x equals 16. Well, I know 4 squared equals 16. Therefore, x is going to equal negative 2. So if it's 4 to the negative x, I need that to be positive 2. So it's like saying 4 to the negative x equals 4 squared. And if negative x is equal to 2, then x would equal negative 2. And again, just using your power chart or guess and check on your calculator, that would work as well. Our next one, log base 3 of 0. Log base 3 of 0. First thing you want to do is set it equal to x, and then we convert it to exponential by looping it. Now our base is 3. 3 to what power equals 0? Well, it can't be 0. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the negative 1 is 1/3. Try other options on your calculator. Decimals. Decimals don't work either. This one has no solution. It's not possible. And if you think about the definitions up above, we can't have our logarithm value be 0. So therefore, it didn't work anyway. All right, let's try that last one. Our last one is log base 2 of 2 to the 8th power. This one's interesting. It has a logarithm and an exponent at the same time. Well, if we set this equal to x, just like we did the rest of them, our base is 2. So that means we're going to take that 2, raise it to the x power. That should be an x right there. Kind of. There we go. That's better. But we're going to set it equal to all of this right here. It's going to be equal to 2 to the 8th power. Well, this one's kind of a no-brainer. 2 to the x power equals 2 to the 8th power. X would just equal 8. And there you go. Evaluating logarithms just by creating an equation, looping, and then either guess and check or use your calculator. Speaking of using your calculator, there are 2 scenarios where you can use your calculator and get decimal approximations. You'll have 2 different options. A common logarithm is when the base is 10. So that little kind of sub number, the base would just be 10. And you'll know it's a common logarithm if the base is not written, which seems kind of strange. So the base is not even written. Take a look at this example on the right. Log of 900. There's no little sub number on the bottom. That means it's automatically a base 10. This is an example of a common logarithm. Anything else like the problems up above where we had log base 5 of 125 or log base 2 of 2 to the 8th, you have to do that looping rule. Here we're just going to simplify it with a calculator. The other option is if you have a natural logarithm. And that brings us back to one of our definitions from the previous lesson. A natural logarithm means your base isn't a number at all. The base is actually e. So natural logarithm is the inverse of that base e. And you'll know that it's never written either. But you'll know that you're using base e instead of base 10 when instead of writing log for logarithm, they do ln for natural logarithm. So that'll be kind of the change up here. Now, the big thing is going to be to find these on your calculator. You have to know where these are on your calculator in order to do this portion of your assignment. Try to find the log button and then the ln button. Again, on scientific calculators, you may have an log button kind of at the top in the middle where all those little programs are. And if you press log, you'll see log, ln, e, and then 10 as a base. If you have a graphing calculator, the log button and the ln buttons are going to be on that left-hand column kind of towards the bottom. And like I said last week, if you can't find it on your calculator, just take a picture of your calculator, send it to me, and we'll get you on the track for that. The nice thing about example 4 is if you can find these functions on your calculator, these go really, really fast. You just plug them in. There's no looping, there's no converting form, there's no guess and check. Let's see how this goes. It says using a calculator, evaluate each logarithmic expression. Now, this is where we have to be careful. To the nearest 10,000th. That's 4 decimal places. Just be mindful of that in the directions, whether they say hundredths or 10,000ths. Make sure you're rounding appropriately for your homework. All right, the first one is log 900. You literally type the log button, enter 900, press enter, and you should get approximately 2.9542. So what that means is 10 to the 2.9542 power is approximately 900. So that's just kind of a check for that result. It's another way to evaluate that exponential statement, but just using your calculator. Now, if we try log negative 14, enter that in, you're going to get error on your calculator. Not possible. We cannot take the logarithm of a negative number. All right, let's try a fraction. Log of 12 fifths. Again, literally type the word log, enter 12 divided by 5 on your calculator. Now this one's a lot smaller. This one's approximately 0.3802. And then the final two are ln's. So make sure to find that ln button or function on your calculator. And it's ln of e. So as you type this in, get the ln to show up, and then e, technically you may have to give e an exponent, and since none is written, we're going to default it to the first power. So ln e to the first power, get this, it's exactly 1. There's not even any rounding. So here's the check for an ln. Remember, ln is already base e. What this means is e to the first power equals itself. That's a quick and easy check there. Now, if it's not e in your ln, if it's ln 22, then we're just going to plug in ln 22, and we get a decimal approximation, 3.0910. If working with these logarithms is kind of tricky and you want to get together on a Google Meet, we can definitely set something up this week to make sure you understand how to plug these things in. That'll be it for our notes today for 6.3. Just make sure to take a picture and submit them for your assignment.